All right. Now we know how to find the equation of a plane using its normal vector. We can now find an equation of a tangent plane to a surface. And here is the formula, and we're going to explain where this formula is from. So we have a surface given by this equation, z is equal to f of xy. This is our surface equation. And we have a point on the surface, and here is a diagram over here we have. So if you look at it over here, we have almost like a dome, and this is what we have over here. And we are trying to find the equation of the tangent plane. That means over here. Okay. So, and we know x naught, y naught, z naught is on the plane. So we already have a point. So the only thing we need to know is to find the normal vector n. And we are going to find the normal vector n using the cross product. How do we do that? We will actually find a vector which is the tangent vector of the cross section of, if you look at over here, is y is equal to y naught intersecting with the dome. So over here, this is 1. So this is one vector tangent to the surface at this point. And we find another vector, b, is also tangent to the surface, but it's in the y direction. So this one is in the x direction, this is in the y direction. And we find these two vectors, and then we use the cross product, and then we're going to find it. Okay, so really, this problem is about how to find the direction of a tangent line in a two-dimensional space. So that's what we're going to explain. But here, let's say look at the formula over here. This is the formula we're going to have for the normal vector. And because your normal vector now is known, so you put into the plane equation, you can see these are the components of the normal vector. And then these are the points over here. You have x, y naught, and z naught. And then if you don't like the negative one on this side, you can add this term to the right-hand side, and then we have z minus z naught is equal to this. This formula over here appears in our textbook. Okay. All right. So now we can explain where this normal vector is from. We look at first the 2D situation to see if we can find the normal vector. Okay. So this is just the xyz plane, xy plane. Okay. And you have a curve over here, and you want to find out what is this tangent line's direction, and this is going to be the normal direction. So this one over here, we're going to find its direction over here. Okay. So how do we find the tangent line's direction? Well, remember, direction is really so-called direction cosine. So if you look at this direction over here, this is angle theta, and this part over here, we have delta x, and this one over here is delta y. So the direction of this line over here is really this. It's going to be, you can see this tangent line's direction. Tangent line's direction is approximately delta x and delta y, and that's what you have. And of course, you can say, oh, well, I can divide by delta x. It's 1 delta y and delta x. And if you let delta x go to 0, this is what we have. We have 1 and dy dx. So we can see this is a slope, right? Slope of the tangent line. So really, the direction of the tangent line is, second component is slope, and the first one is 1. And this will give us tangent lines. Direction. Then how about this line? We just need to remember the formula that if your slope is m, then your normal line slope is negative 1 over m. So you just need to find 1 so that the dot product is 0, right? So if you have normal direction, then you multiply it with 1 dy dx, and that's going to be equal to 0. So you can choose the normal vector to be just dy dx and negative 1. You can see this is what we have. So once we have this one over here, so we can look at now what's going to happen. Suppose you have 3D. So this is z, and this is going to be y, this is going to be x. Okay. Suppose you have a curve over here like this. Suppose you have a curve in the xz plane. And you want to find out what's the direction over here. You find this A vector over here. And how do you do that? According to our analysis, this A vector over here is going to be simply it's going to be simply 1 in the x direction and then dz dx, right? That's what we have. Okay, but in the y direction it's 0, so later on we can add a 0 to the middle. Now, suppose you have a curve which is in the yz plane, looks like this kind. So this is z, this is y, this is x, and you want to find a direction like this over here, b. And how can you do that? Well, you will just write down in the y direction is to have 1. Okay, so y direction is 1, and then z direction you have dz dy. So that's what we have if we have dimension 2 curves. If dimension is 3, then we have the following. If we have z is equal to fxy, and we fix the y, it becomes a function of x. So we have a vector over here. In the y direction, it's going to be 0. So you have 1, 0, and dz dx. Okay, so that's 1. And the b direction, then we're going to have 0, 1, and dz dy. Okay, so this is what we have for the vectors that we actually saw in this diagram over here. A direction is the tangent line's direction in x direction, and b is the tangent line in the y direction. So now we can find cross product and hope it's going to work. So a cross b, we're going to use the determinant method. So over here we have I and j and k, and then put 1, 0, and dz dx over here, and then put the 0, 1, and dz dy over here. And that will give us the direction, the normal vector of the tangent line. So if we calculate this one, then we're going to have 0 dz, 1 dz dy, and that will give us I direction. And then we will look at the j direction. Remember, swap these two columns. We have dz dx and dz dy, and then you have 1, 0. And then k direction is easy because we have simply 1, 0, 0, 1 and k direction. So now we calculate this one. So we have here's dz dx. Let me add it over here. So we have negative dz dx, okay, and then I direction, and then here we have negative dz dy, okay, and then the last one actually is positive 1, and then it's going to be k. Here is j. Okay, so what we have over here is negative dz dx and negative dz dy and positive 1. Of course, we can use either this or we can use its opposite direction. That means dz dx and dz dy and negative 1. And that's our normal vector for the tangent plane, for the tangent plane. And once we have this one over here, then we can go back and get the equation for the tangent plane over here. And that's what we have. All right, that's it.